Hi everyone. I'm Thomas. I'm a backend developer. I've been a backend developer for Malt for now 2 years, a bit more 2 years and a half. And what I'm gonna present to you is a talk that we have already given during what is called our Malt Tech Days, which is basically the product team, well, the tech team gathering up and presenting to each other some subjects. It's kind of free. And what we're gonna talk about today with you is a Rex, which is a French term, by the way. I just translated the slide in French and mistakenly forgot about this, but it's a return on experiences. So it's kind of getting back on the experience and what we gained from migrating from a legacy system. So sorry if the presentation is a bit rough on the edges, but we kind of prepared it quite quickly to be English rather than French, which was the original format. So I'm going to present the core team, which consisted of 6 people at the time: John, Jeremy, Ludovic, Pierre, myself, and Julien. And we worked on rebuilding the conversation application from April to July, approximately 27th. Actually, it turned out to be a much larger work because we had to refactor a lot of what we did, but it released in end of July. So the demo is about what the conversation application used to look like. So I don't know if you've used Malt for, well, some time ago, but this is what the conversation looked like. It was very, very not what it is right now, meaning it was kind of rough to use. Also, one thing that is to notice, and we'll talk about a bit later, is that here you can see that you had a number of conversation with the same person that was there was a number of conversation that was due to the number of project and not the number of intellector or participant. So Paul from Paul Company would appear multiple times in your conversation feed rather than a single time, which was kind of unusual. Also, when we send messages, the UI was really, really rough and was not really, did not give you the a feeling of comfort for writing messages. And that was something that we really wanted to work out. So why revamping the conversation? So we had a certain amount of goals during this this workshop. Well, this work. The goals were to allow multiple persons to be in a single conversation. All right. So as of right then, well, as of then, there was only 2 participants in a conversation that were, the system did only allow 2 participants in the conversation. We wanted to have a system that would allow more participants in a conversation. So it was one of the big goal of this revamping. And also, as I said, we wanted to have conversation unique to a relation. So between 2 people having only one conversation and not having this kind of a spread out project centered conversation feed, which was not really useful. So we had the the design done, and now we had a lot of new technologies prepared to be used on the stack. So we planned on using Vue.js for the front end. And so instead of using our old GSP, so Java server rendered pages, Kotlin, Postgre instead of Mongo, Juke, and Elasticsearch. So those were the technologies we introduced into building Messenger. Those technology were already introduced in other parts of the website. And the thing that was new is that within our team, it was the first time that we used so many new technologies, except that we were very happy to start the project, except that the conversation stack is one of the oldest brick in Malt system, meaning that there was a lot of dependency on this brick. So for instance, missions, the mission workflow would depend on the conversations. Our business intelligence would depend on how the conversation were made. We have an internal lead system that is also based on conversation. Profiles also uses those conversations. So we had a lot of other part of the system using the conversation and the model that was in MongoDB. So it was not just easy, like we had some model that were not used that we can migrate directly into the new technologies we wanted to use or the new model we wanted to use. We had a constraint that it had to be retro-compatible with all of the other systems. And so we decided to create a new application called Messenger that would centralize the responsibility of doing all the conversation. What you see in the UI would be under the responsibility of Messenger. And we wanted to migrate the conversation from MongoDB to PostgreSQL. The reason is we thought that PostgreSQL was much better suited for all the group conversation kind of things. So in this way, we would be retro-compatible and we wouldn't have to change all the other bricks. Like we didn't want to change how profile uses conversation and so on and so forth. We really wanted to stick with this. Otherwise, the work would have been too heavy for us to handle. So now that we know that we want to migrate from one place to another, we need a couple of strategies and a couple of ways of doing that properly. So the first is a strategy to preserve the retrocompatibility of the model that that I've shown just before. And in order to do that, we use a strategy that is very close from BlueGreen Deployment. If you know what BlueGreen Deployment is, it should be quite familiar to you. The idea is that at first we're gonna distinguish between writes and reads. So in red you have what is written to the database, and in green what is read from the database. So right now the conversation at the initial state, the conversation uses writes and reads to MongoDB. And while we have this system, we set up our PostgreSQL instance on the side. We start building up our model on PostgreSQL. Once our model is ready for PostgreSQL, we start by writing what we call double writes. So writes on MongoDB and on PostgreSQL at the same time, while keeping the reads on the MongoDB. This has the effect of making we're sure that if something fails on PostgreSQL side, we're really okay because we're still using our MongoDB instance. So we can have both model at the same time, but we know that we're still retrocompatible with what used to be in MongoDB. And if there's any problem, we can still, fix the stuff in PostgreSQL. Once PostgreSQL model has matured enough, we're ready to apply, for instance, a migration that would force the double write of every conversation from MongoDB to PostgreSQL. And at this point, it would mean that we have the same data in both MongoDB and PostgreSQL. And this is where we're preparing for the next step, which is, of course, to put the reads on the PostgreSQL model. And in this way, but keeping the writes on the MongoDB model. This way we know that if there's any failure in our model, in our PostgreSQL model, we can still go back to the Mongo model. And once we're really sure that we're not doing anything wrong with the Mongo model, we can drop it and use PostgreSQL at only. So is it retrocompatible? Yes, it is. The real advantage of using this method is that there's no downtime. You can always have all your application doing everything, keeping their work just as usual. And you're only gonna do baby steps when you are sure that you can do them safely. So it's really a nice zero downtime method. And so this is why it's pretty close from BlueGreen, because it's, there's an easy rollback, meaning at each step, you can very easily go back from, reads and writes to the other database. So it's pretty sure that, if you make a mistake, you can easily go back and have, a peace of mind in this regard. And the one thing that has to be assured, though, is the verification step. At each step, you really need to know whether the step has been completed or not, because if it's not complete, if your write model failed somehow or something like that, you might really introduce some bad cases and you might skip a step. And so it's really, in French we say ants work, un travail de fourmi, to be able to migrate one model to another. So this is the way we got it. So the model of the PostgreSQL model that we created was basically a 9-table model. I don't know how to say that. It consisted of 9 models, and we constructed conversations back with joins, like SQL joins. And it's a pretty big change compared to what used to be in Mongo. And one of the big changes is that you have to translate all the requests that used to be done in MongoDB into requests for PostgreSQL. And this is a big, Rosetta Stone of translating all the requests. And you really need, I use the Rosetta Stone here because it's really like, you can't just simply do an ad hoc. You're going to see each method, what they need, and create something for each method, because you have a lot of method and usually you don't have the time to optimize the request for each and every method. So you really need to have a translation kind of tool, or at least methodology or protocol. And the challenge is that you change from MongoDB, which has a single model, to a PostgreSQL, which is a scattered table model, where the normalization is kind of key, but also it introduces a lot of complexities compared to what MongoDB offers. And it can really be shown by what used to be our Mongo requests, where you simply have, for instance, if you want to find a conversation from a range of date, you have a simple one-liner to find all those conversations. And the Mongo is, since Mongo returns some kind of JSON, the mapping is also pretty straightforward. If we take the same request in PostgreSQL, sorry, Laurent, I just see your I just saw your comment on the double write setup. Maybe you want to know how you write both on MongoDB and Postgre. Maybe we can talk about it at the end, if you don't mind, because I think I saw your question a bit too late. Sorry. So the same request in Postgre or in SQL is a lot of joins. So it's not a one-liner anymore. And this request is only to find one conversation or to find a couple of conversation. So there's a lot of joins. In this request, there's a couple of things that are really important, which is the order by. And I think I talk about it just a bit after. Yes. The thing is that we're gonna, the first request I showed you is only to grab all the aggregates, so all the conversations, single conversation by single conversation. Well, all the conversation with all their messages and everything. It kind of glues all the model up. And what we need is that we basically do a two-time request. And in the first request, we find all the conversations that we want to grab. So we want to query. So for instance, during in between a range of date. And the very important part is this array positioning here in the request in the order by, because it allows in PostgreSQL to maintain the order within the second largest request. And it allows to keep the order of conversation as they come in. So this was a big thing. And this is it. Sorry, I thought I had more slides on this subject because there's a lot of complexities. So if you have any questions on it, don't hesitate. One other thing that we need to do, so here is only like the request side of things, but we also need to test like all those requests, right? We don't want to be in a position where we, where we kind of do it blindly, the changes, and hope for it to be perfect, because there's a lot of requests involved in such a model that is used everywhere. So to do that, we use what is called the golden master test suite. I don't know if you're aware of the golden master, but it's a bit like Indiana Jones in the first episode, where you need to replace a golden statue with a pack of rice. The idea is that we're going to build a test suite that allows us to replace the golden idol without changing anything, right? So here the golden idol is MongoDB, and we want to replace it with PostgreSQL. The idea of this approach is to have a high level, sorry, I'm gonna skip this one. The idea is to treat the code as a black box. So basically there are some inputs, in our case, the conversations that we want to save, for instance, or we want to do an operation on the conversation. It's the interface that we're using. We have an input, and then the black box has an output. In our case, if I search for conversation in that database, they should look like this, right? So the idea is to treat MongoDB as a black box and to compare the outputs of MongoDB and PostgreSQL when we provide them the same inputs, so the same conversation. So the simplest case of this golden master would be, so given a conversation, if I save this conversation in MongoDB and I save it in PostgreSQL, here it's called Juke repository, we want them to be exactly the same, meaning that if I look for this conversation in Mongo, the result will be exactly the same if I find it in PostgreSQL. This might seem kind of simple as a test, but actually it's really effective because you have a wide variety of scenarios. And the idea is that you don't get into really the specifics of like how it works within MongoDB or how all the treatments that may be made by the so-called black box, and you just kind of rely on the output that is given. And such a simple test is really effective to be safe regarding the building of the model. So for our case, the conversation, what we used is we sampled approximately 100 conversations from our staging environment, and we used those 100 conversations. Well, basically we did a dump of MongoDB in our staging environment. We sampled this dump so that it has only 100 conversation, and we tested the output from Mongo and and tested that the Postgre implementation reacts exactly the same. And this was really a good first step, because it really allowed us to discover some really small intricacies, and kind of it allows us to kind of find what was important in our test and what was not. And also, since MongoDB doesn't have any schema, it allowed us to discover some functionalities that maybe have been lost in the code and that were still in MongoDB, and so on and so forth. So it was really a very nice first step. Then the idea is that we had 13 writing requests, or kind of equivalent to writing requests. So we did basically 15 tests for them. And for the reading request, that was a bit more simple to implement because of the systematic approach we had regarding the translation of the request. So we felt pretty confident having less tests to use here. So I don't know if you knew about Golden Master, but there's a lot of variation on this technique, and it's really, really interesting and effective. So yeah, let's migrate everything, right? Now that we have a retrocompatible protocol, we know that our tests are okay, we can do the things. Well, except no, because we encountered kind of a big problem, and that was really something that hurt us for quite some time during the work, which was the kind of the identity problem. So conversation usually have two identities in Mongo, the client identity and the freelance identity. What we did is that those were denormalized in Mongo, and we normalized them in our Postgre model, meaning that for every identity, there was a type, client or freelance, and that was a kind of unique, there was a unique constraint on those type. And the thing is, the constraint warned us that there's a lot of conversation that did not comply to that, meaning that in what was called freelance identity, there might be something, well, an identity that was used as a client identity in another conversation. And there was things really weird of this kind. And this was a lot of bugs that we had to treat. And we spent a lot of time trying to understand all of the cases in which this case could happen. And it took really, really a long time to understand exactly what happened and why those identities were mixed up in MongoDB. And there were even some conversation that we're not able to find what really happened. So it was kind of a problem because we were trying to do something that is not really good when migrating things. I think it's fixing the data while you're migrating. And we were really, I think it really improved in terms of for the data analyst and the people using our data to know that the data is consistent compared to what used to be. But the problem is that it took a long time. So it took 2 weeks worth of work. We were not guided by data analysis, meaning that we were not able to say how many conversations were affected by that. So it could very well be 100 conversation or 10,000. We didn't have any data regarding this. And so we were completely blind whether it was useful or not. So this is a graph down there that I don't know if it's really useful, but basically we considered that the green is basically all the conversation that we were able to migrate, the red, the one that we were not able to migrate, and then there's a tiny bit of orange in between that is less than 0.1% of the conversation that we're able to migrate while fixing the data. So definitely, I think those 2 weeks of work were not that useful compared to the return on investment that we had. And I think the big mistake was not being guided by the data analysis of what our data set was to start with. And so the migration was done, well, at one point. The problem is that the migration, even once done, was not exactly on point. We had problem of concurrency. So we're using in Malt. I'm sorry I didn't use slides to introduce our architecture regarding that, but I'm going to spend a little bit of time explaining that. We're using RabbitMQ. I don't know if you're used to, which is a event, well, messaging queue technology. And we're using that to send messaging queue on the system. And basically, when we used to be with Mongo, we had each operation was in its own transaction. And the problem is that with the usage of PostgreSQL, we were able to use transactions, right? So with commits and everything. And the problem is it's really shocked with our usage of RabbitMQ. I'm sorry, I'm gonna, okay. So for instance, in this scenario, we have a first event, event A, which finds a conversation by ID, changes the data on the conversation, saves the conversation, throws an event of type B, and then do other stuff. I don't know what the other stuff could be, but I don't know, sending mails, changing parameters on an account, whatever. It means that when we throw the event B, there's a listener on the other side that will catch the event B, that could I don't know, that could find the same conversation by ID itself, changing the data and then saving the data to PostgreSQL or to MongoDB in this case. The problem is that if you use PostgreSQL, sorry, I don't know these slides very well. The problem is that if you use PostgreSQL, if you're used to that, what will happen is that the transaction will not be committed after the save, but it will be committed after you finished the so said other stuff. And that means that you have sent an event to RabbitMQ while the transaction is not finished. And so probably, most probably, even B will not have a version of the conversation that is coherent. And so this is a big problem. This is a big problem because it means that even B will not work with the right data set, and it might even override operation that the event A did on the conversation. To solve this problem, we used so-called transactional event B, or this is how we call them, transactional, meaning that we monitor the transaction within the handler of the event. And what we say is basically the event will not be sent until the transaction is committed. And so this is the small arrow displays where the transaction is committed and where the event is thrown, is fired. And so it means that event A and event B will, well, event B will have the correct version of the conversation. So this was, oops, sorry. This was a first problem that we had with transactions within MongoDB, well, within PostgreSQL. It was actually a known problem that we already faced during another project. So we already had the solution, but we needed to put it away. Another problem that we faced that was much harder to debug and much harder to find is another concurrency problem. This time, instead of having two events, we only have one event, the event A, with two listeners on the same event. And each of those listeners do some stuff, and they also change the data in the conversation. The big problem with this concurrency issue is that there is absolutely no, well, the behavior is incoherent, meaning that if you run it once, it might have a certain behavior, and if you run it a second time, it might have another behavior. The thing is, in MongoDB, we had already this problem, but it was not visible because we just didn't have transaction that would tell us that there was problems during the execution. But this time, the fact that we had transaction within PostgreSQL made the problems really well visible, because it would happen a lot more than it would in MongoDB. And in order to fix that, we used a select for update That is a tool in MongoDB in PostgreSQL that allows you to lock a database, lock a row, or lock a table. It depends on what you select, but it allows you to put locks on objects and to make sure that everything is synchronized within the select for update. So in this case, the first listener will acquire the lock through the select for update, and until its transaction has committed, all other listeners that would use also the select for update will have to wait until the first transaction is released. And this is a very simple one-liner to put, and it allows you to create pessimist locking on the database. And in our case, it was the only solution that was, well, that was easy to put to solve the issues we had with those select for update. So this is almost the end of the slides. Was it worth it? It's a question that really tackled us because we were very enthusiastic to use all those new technologies at the beginning of the project. But in the end, we had a very conflicted feelings about it. And I think it's due to the fact that the migration was not as simple and straightforward as we thought it would be. And we spent a lot of time during this migration. So is it worth it? I think that the final result of Malt conversation is pretty good. I think so. We can't say that it was complete loss, right? But I think we went a bit too far regarding the migration, and I think that next time that we have such a project of migrating large thing, I think we'll be less ambitious regarding migrating all the model and all the UI and all, everything at once. I think it's really wiser to have a much weaker scope, but to be focused on it rather than spending a lot of time migrating things. But there's a positive thing, which is the KPIs, because we have, since we released the Messenger app, we have a lot more messages per month, a lot more messages per users, which means that I think it shows that the new UI is a lot more intuitive and feels a lot much comfortable than the older one, which was kind of really old, I would say. And also the answer delay, which is a very important metric for our freelancer and for our client, decreased a lot. And I think it's due to the functionalities that we baked in and the intuitiveness of the application. Do you have any question? So I think that Elga is asking how much time from the start of the project and how many people working on it. At the start of the presentation, so I talked briefly about it, but maybe I can speak a bit more about it. On the migration itself, we were 2 developers. On the overall Messenger rework, we had a team of 6, consisting of 1 product manager, 4 backend developer, 1 front-end developer, and a tester quality. But yeah, so this is, I think more 3 backend developer because one of us left pretty early. So I think it's much safe to say 3 backend developer. And the start of the project is mid-April, and the end is July, end of July, sorry. Also, Laurent Roger, you had a question about the double write-up, and I'm not sure if I understand exactly what you mean by setup. Can you say a bit more about it? Oh, you mean without downtime. So the idea is that conceptually, um, uh, if you have your writes on the, well, if you have a double writes, meaning that if you write everything on two database, it could be MongoDB, it could be something else. Huh? If you write all your things on the two of them, it means that you don't need to stop a database, migrate all the things, and start another instance. So it means that you can live with both of the database instances at the same time. So it means that you can change your application, I mean, your database and everything. Yes, yes, of course. I'm not talking of the, well, so the downtime I meant was that the migration, well, if you don't want a downtime, it also means that you need to have a blue-green deployment of your applications, right? So this is not something I talked about it, but we also have a green and a blue-green deployment. Elga, you ask that if I had to do the same thing from scratch, which database would I now prefer? Although the MongoDB is the ecosystem is really is getting a lot more. I think it's getting much and much richer. I think that I will still stick on PostgreSQL because I think the constraint that are allowed, I mean, that PostgreSQL allows you to make are really powerful and is something that you cannot find in MongoDB. Also, the language SQL is really expressive and you can really do a lot of things very easily compared to in MongoDB, you use the aggregate system, which is a lot more difficult to use. So I think I would still use PostgreSQL from scratch for sure. Are there any other questions? If okay, so Laurent Roger asked why Juke. It's an internal debate actually within Malt, within our team. Basically, we have, let's say, the leads are not very fond of Hibernate, which is the technology in Java Spring environment. Because of how Hibernate does a lot of things for you, but it also is all the magic it does means that there are some things that you cannot explicitly ask. And so we were looking for something that would allow us to write raw requests. And we were hesitating between Juke and MyBetis. I don't know if you're aware of those two. And in the end, Juke won mostly because of the documentation. MyBetis has a lack of documentation compared to Juke, and I think it means that using Juke is much more safe in terms of development. When you need to find something, you usually, if you look into the documentation, it's pretty good, pretty well done. And you heard about PHP in your backend, but where is Java? I don't know where you heard of PHP in our backends, because our backend is made with Java since the beginning of the stack. So we really are not PHP users. We only use Java, Kotlin. Now we start using a lot of Kotlin, but yeah, historically Java and Spring input in terms of backend. No problem. Well, anyway, thank you very much for your presence here, and sorry for the rough edges on the talk, and I hope you really enjoyed it.